With this video, I'm going to go through the entire lesson of synthetic division. Now, this one is going to be a little bit more of a lengthy video, but it'll go through the entire lesson, give you some chance to practice some on your own and check your answers. So, the objectives for today's lesson are we want to be able to learn how to actually use synthetic division to divide polynomials. Now, we've already learned how to divide them using the long division method, the algebraic long division, but we're also going to learn how to do it using the synthetic method. Now, the synthetic method will work only sometimes, only in certain scenarios. We're going to go through that. So you've got to know when to be able to use the long division method versus the synthetic division method. And the synthetic division is quite a bit faster. So most students like to use that if you can. The algebraic long division, that one will work all the time. So no matter which way type of problem you get, that one will always work. I want you to go ahead and try this one. Go ahead and use long division to find out the answer on this. So go ahead and do that now. Push pause whenever you're ready. Come on back and then you can check your answer. Check your answer here. Hopefully this is what you got. The remainder on this one was -5 because the remainder was -5. Then we go -5 over x minus 3. Remember that this x minus 3 is what goes on bottom. Okay, so that's using the long division method, and that method works again all the time. The problem with it is it's very, very prone to error because you have to bring this number down. Then you're going to have to change the sign on both. You've got to remember to do all of that. Sometimes it gets fairly confusing and very, very error prone. So there's a better method and a faster method called synthetic division. And with synthetic division, we're going to do these right now. The thing that you need to know, it works as long as the leading coefficient here of the one that you're dividing by is 1. It has to be a 1. If this were 2x minus 3, this would not work. You would have to use the long division method. But this number right here, way out in front, has to be 1. All right, so the very first thing that we're going to do here is I'm going to write down the coefficients of each one of these. The coefficient of this one is a 1. Okay, the coefficient of the middle term here is going to be -2, and then the constant at the end is -8. So we're going to write all three of those down. These are just the numbers. We're not going to deal with the variables at all. We don't really care what those are at this moment. We will add those back in later on. All right, now what I'm going to do is draw a box around it, and then I'm going to write a number out in front here, and that number is going to be basically the opposite of whatever this number is. Right now I've got a -3. So that means the number that I'm going to write out front here is going to be a +3. Now I know this is sounding very confusing and kind of a little weird, but bear with me as we go through it a couple times. It'll become very, very easy. All right, so again, my 3 here came from right here, whatever this number was. If this were a 7, a x plus 7, then I would do a -7 out in front. So whatever the number is in here, basically you're going to change the sign and move it out in front. Okay, now as we're going through this process, it's going to be very, very repetitive. So after you get it down once or twice, it will become a lot easier. The very first thing I'm going to do is bring down this 1. I'm going to bring down the 1. I'm going to write it right down here, all the way down. Now then, I'm going to take this 3 and multiply it by whatever's on the bottom. So I go 3 times 1. Well, 3 times 1 is 1, so I'm going to write that right up here. You're going to see this pattern go through all the way down, okay? Again, this 3 here came from 3 times 1. I didn't just move this 3 over here. If this number here were different, then I would multiply those. All right, so now I've got the 3 here. Now I'm going to add these two. -2 plus 3 gives me a +1. And I write it right down here. Then I go over here and I go, okay, 3 times 1. 3 times 1 is 3. So I'm going to move it right up here and I'm going to rewrite it. Then I'm going to add these two together. -8 plus 3 gives me -5. Okay, now we're seeing some similarities here. I've got a -5 here and my remainder over here was -5, and that's not by chance. So that is the answer as well. That's your remainder. All right, so let's go back through here. These are your leading coefficients. Okay, this is your remainder. Then we go to our constant, which is 1. Then we go to the next one over, which is our linear term, which is x. Okay, now I went through this one fairly fast. The next one I'm going to go through very, very slow, just to give you some practice here. But what I wanted to show you on this one was that these two get you the exact same answer here. Once we get all these numbers here, we're going to convert these back to a quadratic, an expression here. Whatever your answer is. In this one, it's 1 is your constant, 1x is your linear term here. But these two are the same. Now let's go through one and let's spend some time on it. This one is a fairly lengthy one, but it gives us a good chance to kind of practice a little bit. So the very first thing that I'm going to do here is write down all of these coefficients. All right, so the first one is a 5. The coefficient on this one here is a 1. The coefficient here is -5. So we're just basically writing down just all the numbers. We're not worrying about the variables yet. And this one I'm going to go a little bit slower on than I did the last one, just trying to give you a little bit better idea of what we're doing here. And of course the last one is -1. We do write down the constant in this case. Now I'm going to move these, let's see, and that'll be okay. So I'm going to draw my box around it now. Now that I've got my box around it, the number that goes out in front here is going to be whatever this number is right here. Okay, and this number, but we're going to change the sign. So right now it's a -1. That means this number that we're going to write out front here is going to be a +1. So I changed it here, this +1. And again, if this were a +1 here, I would write a -1 out in front here. All right, the very first thing I'm going to do is bring down this 5. Bring it all the way down just like it appears. So I bring the 5 all the way down. Then I multiply this. I go 1 times whatever this number is here. In this case, it's 5. So 1 times 5 gives me 5. Then I'm going to add. So it's going to be a multiplication and an addition every single time. Now I'm going to add it. 1 plus 5 gives me 6. Now I go back through here and I multiply. 1 times 6. Again, this is a very repetitive process. After you do it a couple times, it does become very easy. So 1 times 6 gives me 6. Then I'm going to add these two. -5 plus 6 would give me 1. I'm moving back down here. 1 times 1 gives me 1. Then I add those two. -1 plus 1 gives me 0. Okay, now we've got all of our numbers down. Now what we're going to do is convert this back so that we know what our answer is, because we know our answer is going to have these m's in them. Okay, so the very first thing I do is I always section off what my remainder is. And so I always draw a box around it. It makes it easier for me. The remainder on this one is 0, and that becomes very important. When a remainder is 0, that means that this, whatever this factor was, in this case it's m minus 1, is a factor of this one. It goes in evenly. There is no remainder on this one. So it will actually be a 0 on this one. That's going to become important for our future lessons. But right now we just need to know that it's 0. So if the remainder is 0, I don't have any remainder over here. The next thing I'm going to do, I'm going to work right to left. So I'm going to start right here and work my way toward the left. Okay, so this one's my remainder. The one next to my remainder is my constant. Constant is the one that's just a number, no variable. So I'm going to rewrite that one. My constant is 1. It's a +1, so I wrote +1. The next one is a linear term. That's going to be just the m. No m squared and anything like that. Just an m. And we're going to end up writing this one in standard form. So I've got 6m, and that's a +6. So I wrote +6m. And the last one that I have is 5. Now I need to go higher. Okay, so this one didn't have any variable next to it. This one was a variable to the first power. This one's going to be a variable to the second power. So it's going to be 5m squared. So this is my answer here, 5m squared plus 6m plus 1. That's it. There is no remainder because my remainder was 0. And 0 divided by anything is always 0, so there is no remainder there. But this is my answer, 5m squared plus 6m plus 1. Now, this process is fairly complicated. So I want to do another example here just to get some more practice in. But this next example, I'm going to give you one that's very, very complicated, just to give you the practice here. But this part here gets to be very, very repetitive. And then at the end, we're going from right to left to rewrite our answer. Okay, so let's bring in the more complicated one. And this one is about as complicated as you'll see for synthetic division. So I thought I would go through every part of this one. We're going to use the same exact process, though. It's just has some more numbers in it is all. All right, so the very first thing I'm going to do is write down all the leading coefficients. And I took the shortcut and just wrote them all down, but I've got a 1 here, a 5, -4. You'll see that this correlation occurring right here, okay? So I've got all those down. This first thing I did. Now I'm going to move it over to the right just a little bit, just so I have some room. Okay, but that's where all of these came from. Okay, here are all the coefficients, same thing. I just moved them over here, so I had a little bit more room to work. That was all. All right, now I'm going to draw the box around it. And the number that goes outside here, now is the opposite of whatever this number is here. This is a positive 4. That means that one that needs to go out front here is going to be a negative 4. Okay? And remember, we can do synthetic division as long as this number out in front here, this coefficient here, this leading coefficient is 1. It's got to be a 1. If it's not a 1, then we can't do synthetic division. We've got to do the long division. But in this case, it is, so we're okay there. All right, so I've got negative 4 out here. Now, the very first thing I'm going to do is bring down this 1 right here and write it right below. Okay, so I bring down my 1. And then I'm going to multiply this negative 4 times whatever this number is down here. In this case, it's a 1. So negative 4 times 1 is negative 4, and I write that right back up here. Now, I didn't use the little arrows. Hopefully you can see where this is coming from. If you want to use the arrows on yours, many students find that to be easier. That's fine. And I've got 5 minus 4 is 1. And again, I go through the process again. Negative 4 times 1 is negative 4. Then I add these two. Negative 4 minus 4 is negative 8. Then I'm going to multiply these two. Negative 4 out here times negative 8 gives me a positive 32. Then I add these two. Negative 39 plus 32 is going to be negative 7. Then I go back over here. Negative 4 times negative 7 gives me positive 28. And this process occurs all the time. We're going to add as we go down, and then we're going to multiply as we go in this diagonal here. Okay, so negative 22 plus 28 is going to be 6. Negative 4 times 6 gives me negative 24. 22 minus 24 is negative 2. Okay, so now that we've got all the numbers down, I want to section off this last one. I always do that with a box. It makes it easier for me. I know that this last one is my remainder. So now I can start to kind of fill out my polynomial, whatever I have left, the division of these two. And I know that it's going to be, my remainder is going to be negative 2. So I'm going to section that off. I'm going to do that in just a moment. This one here is my constant. That means it's got no variable next to it. It's just plus 6. This one needs to have a variable next to it. We're going to go right to left as we go across here. So the variable in this case is an a, so this needs to be negative 7a. Well, the one next to that one can't be an a again. It's got to be something different. So we're going to increase the power on it, the exponent. Instead of this exponent being 1, and this one's going to be a 2, so it's going to be negative 8a squared. And as we go over here, this one's going to be a 1 as our coefficient, so it's going to be plus a cubed. The last one is going to be a to the 4th power. Now let's look here. If you'll notice here, we're going to go down every single time. This has an exponent of 4, then 3, then 2, then 1. Then there is no a here at all, and that's what we want to do. Okay, we're going right to left, and we increase it by 1 every time, which means that as we go down, it will go down by 1 every single time. Okay, so our answer here is this one. This is the exact same thing that I just wrote here. A to the 4th, a cubed, negative 8a squared, negative 7a plus 6. Here's my remainder. This is the negative 2 over, and it's going to be over whatever this is right here. Okay, not this negative 4. It's not going to be negative 2 over negative 4. It's going to be my original one that I was dividing by. In this case, it was a plus 4. Basically, when you're looking at the synthetic division, it's always going to be a binomial. That means that it's got the 2 parts, so a plus 4. Okay, now, it'll take a little bit of practice on this one, but you'll find out that this one gets to be quite a bit faster. All right, so let's bring in a couple here. Here are 2. I want you to try these 2. Go ahead and set those up. Remember, the first step is to write down your leading coefficients, then to make the box, then to switch the sign here. So this first one, I'm going to switch the sign to be negative 2 on the outside. All right, so go ahead and write those down right now. Work out your problem, push pause, and when you obtain your answer, come back in and push play. Check your answer here. Now, remember on this one that when we write our remainder, this is going to be an n plus 2 here. Okay, this is not going to be a negative 2, but an n plus 2. And you need to remember that we're going from right to left. This one is a 9, then we add a 3n, then an n squared. Remember, we do not write the 1. And same thing on this one down here. We're not writing the 1 out in front. And it's going down in descending order here if you're reading left to right. 3, 2, 1 as our exponents here. All right, let's get some more practice on this. Try these 2. go ahead and push pause when you're ready. And then after you've completed your problem, come back and push play. Check your answer here. All right, now let's look at number 2 just real quick here. This one has no p cubed term. So if it's got none, then we're going to need to write a 0 here, okay? This one also has no p term. So we've got p to the fourth and 0p cubed, 5p squared, 0p. So you'll notice that I'm using zeros here. That's going to become important because that will change your whole lineup here. So if you didn't do that, it'd be good to get a little bit of practice. Go back in and redo this one just to get a little extra practice on it. This one had no remainder on it. So because it had no remainder, we're not going to write anything after it. Now that becomes important whenever we have a 0 as our remainder. That means that if I were to multiply this p minus 1 times this right here, this polynomial, this p cubed plus p squared plus 6p plus 6, we would get this original and this original portion right here. Okay, this is a factor of this. This is also a 0. If we're trying to solve a problem here with this one, we'll find out that 1 is a 0. We'll get to that in a future lesson, but that's going to be important. You want to be able to recognize those when it has a 0 as a remainder, then this number, this portion here that you divided by, is a factor of the original one, okay? It's an exact factor of it. There is no remainder like there is in number 1 has a remainder. Number 2 does not. All right, go ahead and try these two. Whenever you're, push pause now. Whenever you're done, come back and push play. Check your answer here. Again, on number 2, we had 0 as your remainder. That means that this m minus 5 is a factor of this one. It does factor in evenly. Okay, we can find some zeros on that very, very quickly. Again, we'll get into that in a future lesson, but the big thing is to be able to recognize that when you have a 0 as a remainder, that this portion here is a factor there. All right, let's go through and try. I'm going to kind of, yeah, let's try 2 more. Go ahead and try these 2. All right, well, number 1 threw you for a curveball. If you notice here, there is no n. There is no just plain old, we call that a linear term, one that's just an n. In this case, it is n squared, and then it drops down to a constant. So we do have to write in the 0 here. Now, on your answer, I've got several zeros here. Okay, I've got n squared. Notice how I just wrote this out. I like to do that. It makes it very clear to me. 0n plus 0. Well, we don't write 0. 0 times n is just 0, and then we don't write the 0 here. So notice how I condensed this here. I've got an n squared minus 7 over n minus 9. Okay, I just condensed that down because that's going to be your answer here. And again, on number 2, again, we had a 0 remainder. That means that this x plus 1 is a factor here. If we were again to multiply this portion right here by this x plus 1, we'll get our original one here. All right, so that concludes today's lesson. If you'd like to, you can go back in and kind of review it a couple times. Hopefully that's helped. But the big thing is just getting that practice down. If you can go, whenever we're bringing it down, we're adding, and then we're going to multiply as we go diagonal here. Just get a little bit more practice on that. I think that you'll find it beneficial. I do have some other videos with specific problems as well, just individual problems.